Welcome to circuitry of the Healthy Harold truck. Today I'm going to explain and show how I created the circuits within the truck and how I will explain this to primary school students. In the educational context, the model is targeted towards stage 3, year 6 and the knowledge and understanding outcome physical world, as students will explore the understanding of how energy is transformed from one form to another. To begin, we'll first explore what electricity is. So what is electricity? It's the flow of electrons. It's a form of energy that comes from electric energy. Electricity can stay in one place, called static electricity, or it can flow from one place to another, which is called current electricity. Electric energy is the movement of tiny little particles called electrons, and these electrons need a conducting wire to be able to flow. An electric current is the flow of these particles that can be converted from electric energy into light energy, into movement energy, or into sound energy. An electric circuit must have a closed path for the electric current to flow through. Some everyday examples include an oven, where electric energy is converted into heat energy so that you can cook, or it could be the light in the room, so turning on a light globe, where electric energy is converted into light energy and with a small byproduct of heat energy as well. When we connect a battery to a wire, free electrons flow out and into the wire, but to be able to move freely, they actually need a push, and this push is called voltage. The higher the voltage, the greater the push or the force, and that means that the globe will glow brighter or a motor will spin faster the more push it has. So what are batteries and what are cells? We typically know this as a battery, but scientifically it's actually a cell. It only becomes a battery when we join two or more cells together. It's the chemical reaction inside the battery that converts the chemical energy, which then converts to electrical energy and flows along the wire through to a globe. So when it goes through the globe, it turns into light energy, or through a motor, kinetic or movement energy, and through a buzzer, it converts to sound energy. The electrons flow from the negative terminal of the battery, through the wire, through the resistor, and back to the positive terminal of the battery. Even though we now know that this is the way the electrons flow in that direction, the conventional method, which is taught in primary schools, is that the electrons flow from the positive terminal through the resistor and back to the negative terminal. Larger cells, like a C or a D size, they're actually bigger, so they hold more chemicals, whereas a AAA, for example, is much smaller, so it holds a lot less chemicals. Even though they're both 1.5 volts, because this one has a lot more chemicals stored, it'll actually last a lot longer. In the model, chemical energy converts into electric energy, then from there it converts into light energy in the globe, kinetic energy through the motor for movement, and into sound energy for the buzzer. And it's important to note that energy cannot be created or destroyed in the universe, it merely changes from one form to another. In the model, we have 5 parallel circuits and 3 series circuits, and all are connected to one battery, which is the 3 volt, 2 cells joined together. The series circuits include the front lights, where you can see one taken out will stop the whole circuit altogether. The rear lights, again, one globe removed will stop the entire circuit. And the motor that spins Harold, which is joined to the 2 globes here, which we use to slow it down. The parallel circuits include the buzzer, which can be turned on and off independent of anything else working, as well as the main motor. In a series circuit, there is only one path for electrons to flow, and a series circuit must include at least 2 components wired in one loop together. Parallel circuits offer many different loops or pathways for electrons to flow, and each loop will contain one component and can be switched on and off independent of the other loops. Series circuits can also be wired in parallel with other circuits. Advantages of the series circuit are that the battery will last a lot longer. All of the components wired in series share the voltage of the battery, so they don't draw as much from the battery, which means it lasts longer. Disadvantages are, as mentioned, if one of the components dies, or for example if the globe's removed like it was on my model, it stops the entire circuit from working. Parallel circuits, on the other hand, work independently, so if a globe dies, all the other components will still work. One of the disadvantages with a parallel circuit is that the battery will die much faster, as each of the loops is delivered the same 3 volts, which draws on the battery much quicker.